In the summer of 1977, a giant dish in Ohio was listening to the sky. It was pointed at an unremarkable spot near the constellation Sagittarius. It listened for hours and heard nothing, just the faint hiss that comes from everywhere in the universe, the sound of empty space. And then out of the blue, the static broke. For 72 seconds, it picked up an intense signal sitting almost exactly on the frequency of hydrogen, the most common element in the universe. The one frequency astronomers had guessed another civilization would use to say hello. The dish recorded the signal's strength as a series of letters and numbers printed on paper. A few days later, an astronomer looked at the printout, circled the sequence in red ink, and wrote down a single word in the margin. Wow. For decades, we went back to that same place in the sky, with better instruments every time. We listened for days, months, years. It never came again. We don't know what it was, and we probably never will. All we know is that one summer, we heard something before the silence took it back. Look up at that same silent sky, and an old question comes creeping in. Where is everyone? The answer is among the most haunting things we know about the universe. And the closer we look, the harder it gets to look away. Let's begin. Start with the numbers. Our galaxy holds roughly 200 billion stars. Most of them have planets, and most of those planets are older than Earth. Billions of years older. While Earth was still an unnamed sphere of molten rock, these worlds had already cooled, settled, and formed oceans. The stage is enormous, and we arrived late. If life is anything other than a one-time mathematical glitch, someone else should have started before us. And it only takes one. A single civilization anywhere among those 200 billion stars wouldn't need crazy physics we can't conceive of to cross the galaxy. There'd be no need for warp drives. Only patience and a single type of machine. A probe that can fly to a nearby star, mine the asteroids it finds there, and build 2 copies of itself. Those 2 fly to the next stars and build 4, then 8, and so on. A wave of life. Let that math run, and the wave crosses the entire Milky Way in a few million years. Make it 100 times slower, and it still takes less time than it took life on Earth to crawl out of the sea. Against a galaxy that is over 13 billion years old, that's a rounding error. There has been enough time for a wave like that to wash over the galaxy hundreds of times over, before the first human ancestor ever learned to walk upright. The galaxy should be crowded and loud. The rock of our own moon should be littered with evidence. But nothing has ever turned up. We are standing in an empty house with the lights on and the dinner table set. The front door has been left wide open for 4.5 billion years. And nobody is here. The scale of this silence is very disconcerting. When we think of alien civilizations, we think of them as equals, roughly comparable to us, slightly ahead of the curve maybe, with technology perhaps a little more advanced than our own. But this is not an accurate way to think of them. It's not how the universe works. Humanity went from horse riding to moon landing in less than a century. We went from the first radio transmission to sequencing the human genome within a single lifetime. Now imagine what a civilization that had a 1,000,000-year head start would be like. Just a 1,000,000 years. A fraction of the age of the galaxy. A species with that much uninterrupted time doesn't just build better ships. They outgrow their planet. To fuel a 1,000,000-year empire, they harness the raw energy of their star. They dismantle dead worlds to build swarms of solar collectors until the star itself disappears behind machinery. A caged star, a Dyson sphere. If they did this to just one star, it might slip past us. But do it to 100 billion stars, and the galaxy changes color. The heat from the waste of a harnessed star would bleed out into the dark, and the sky would be glowing in the infrared. So we looked. A team went through every galaxy the infrared map of the sky could resolve. 100,000 of them, looking for anyone burning through a galaxy's worth of starlight. Nothing. Billions of years for life to reach the level of gods, and yet, nothing. It implies a limit. There must be something that stops them. And not just once. Every single time. Somewhere on the long path from an unremarkable rock to the gods of the galaxy, there is a wall. A barrier of some sort. Something that stops every civilization cold in its tracks. We call it the Great Filter, and there is something very disturbing about it. Whether the wall exists or not is hardly the question. The silence of the night sky practically guarantees that it does. What's disturbing is the question of where the wall is. Behind us or ahead of us? If it's behind us, then the hardest step was the very beginning, the spark of life itself. Or perhaps the jump from single cells to complex organisms. If that's the case, then whatever impossible hurdle sterilizes the universe, we already survived it. Without even knowing, we left that wall far behind us long ago. We made it, and we are one of the few civilizations that ever will. In that universe, the silence is just the sound of how incredibly rare we are. Alone, but safe. But if the wall is ahead of us, if the spark of life is actually quite common, and planets routinely grow oceans and forests and animals, but the thing that kills them comes later. If the thing that ends civilizations comes after they've invented radios and split the atom, then the meaning of the silence changes. We're no longer in an empty house. We're in one of a row of houses where the lights went out, one after another, right as the people inside them thought they had finally made it. It means every one of those 200 billion stars is a place where someone may have lived, just like you are right now, right before whatever comes next came for them. There's a way to find out which story is true. Every time we send a rover to Mars, we are looking for life, a microbe, a fossil in the dirt. If we ever do find it, it will be the biggest headline in history. But finding life on Mars might prove nothing. It could easily be our own. A meteor strikes the Earth, throws a piece of rock into space, and that rock drifts to Mars, with stowaway microbes from Earth. Rocks have been crossing between the two planets for 4 billion years. Life on Mars could be a distant cousin. It would only really matter if it were the other thing. A second beginning. Life that started on its own. And if life did start twice, on two neighboring rocks, then the spark is not the hard part. It's common. And the beginning was always the safest place for the wall to be, because we're past the spark. We're already here. That's the one reassuring answer, that the hard part is behind us. A second Genesis on Mars would take that away. It would mean that the odds are the wall is still ahead of us. There are people who think about this for a living, who will quietly tell you that they hope we look and find nothing on Mars. Because for them, the most frightening thing we could find out there is a second beginning. For a long time, the Great Filter was the darkest answer we had. The idea was that civilizations simply destroy themselves or are wiped out by their own technology before they can cross the galaxy. It isn't the darkest answer anymore. What if the silence is a choice? In 2008, the Chinese science fiction writer Cixin published a thought experiment, a sociological exercise based on cold game theory. It requires you to accept only 2 axioms about life in the universe. 1. Survival is the primary need of any civilization. Whatever else a species wants, its fundamental drive is to keep existing. 2. Civilizations will continuously grow and expand, but the resources in the universe are finite. If those 2 rules hold true, the cosmos becomes a paranoid place because of a concept called the chain of suspicion. On Earth, if you meet someone for the first time, you can have a conversation. You can see them and hear them and get a good idea of what they're like. But you cannot do that across light years. If you detect a civilization 100 light years away, you can only see what they were like 100 years ago. If you send them a message asking for peace, it will take 100 years to get there. If they reply, it will take another 100 years to hear them. Civilizations do not grow at a steady pace. They accelerate. They jump from one technology to the next. In the time it takes a message to travel to and fro, the civilization you spoke to might have gone from the steam engine to a weapon that can crack a planet in half. You cannot know what the thing in the dark has become while your message was traveling, or its intentions. The weak, primitive light you spotted in your telescope might already be a civilization that has the power to end you. And even if they are peaceful, you cannot know if they believe you are peaceful. Time and distance force both sides into the same position. If you can't be sure they're safe and you can't afford to be wrong, what is the best course of action? You do not talk. and you don't wait to find out if they are friendly. The safest move is to strike first. Wipe them out while you still have the advantage, before they have the chance to wipe you out. If Cixin is right, that is the whole game. A silent standoff between every civilization in the dark. And the only way to win is to fire first. If the universe works this way, everyone capable of this reasoning would arrive at the same cold conclusion. The silence of the cosmos is not the sound of an empty house. It is the sound of a dark forest at night, of predators and their prey, of every creature holding its breath, waiting for the others to make a sound. And the first one to make a sound is the first one to die. The frightening thing about the dark forest isn't just the fact that someone might be listening. It's how they would enforce the silence, how they'd make sure no one else ever finds them. If you are an advanced civilization and you have accepted the rules of the dark, you do not sit on your home world waiting to hear a radio signal from another world before you launch your attack. The distances are too great. Delay is too dangerous. By the time you hear the signal, load your weapon, and fire it across the void, thousands of years might have passed. The primitive species you heard might have evolved enough to deflect it. So you don't wait. You automate the execution. You build von Neumann probes, self-replicating hunter-killers, and you launch them in every direction. There's a name for them. It comes from science fiction, from a series of stories written in the 60s. Berserkers. They fly to every young star system, every cloud of gas where planets are forming, and they hide. They bury themselves in the asteroid belts of a billion unformed worlds, and then they go to sleep. They power down and blend in among the asteroids. They stay perfectly quiet and just wait for millions of years. Their only directive is to listen for the one thing that proves a species has crossed the technological threshold: unnatural radio waves. The moment they hear a signal from another world, they wake up. They don't need to send a message back home. No permission is required to take action. And the actions that they take are nothing grand. When one wakes up, it simply builds a small impactor out of the rock it was hiding in. Or it reaches out and nudges something that is already nearby into a path that ends in collision with the planet that made the noise. It delivers an extinction-level event within the solar system and then goes back to sleep. The civilization is destroyed, and the machine moves on to the next one. If this is how the dark forest works, then the silence of our solar system is an illusion, and we are sitting in a minefield, surrounded by machines that have been waiting millions of years for something to make a sound. And for the last 100 years, we have been loud. We have no idea if right now there is a sleeping machine buried somewhere in the Kuiper Belt, powered down in the cold, silently recording the noise we've been making, waiting to be sure. Now go back to where we started. 72 seconds of radio signal arriving from Sagittarius in the summer of 77. Perhaps that was a civilization reaching out to us. If it was, We don't know how far the signal came, and we can't know. In the long history of our own civilization, we have been careless with our signals, the opposite of quiet. Most of our noise is no problem. Our early television broadcasts and commercial radio signals are too thin to be heard by the time they reach the nearest stars. If anyone is out there, they are not secretly watching our old sitcoms. But there is one signal that is loud enough. Radar. The powerful military and astronomical radars that sweep the skies for incoming nuclear missiles. They have been around for a long time. They have been sending out powerful directional signals, searching for something to destroy. They are the loudest sound this planet has ever made. But they are not the loudest mistake we have made. On the 16th of November, 1974, we finished a major upgrade to the Arecibo Observatory in Puerto Rico, the largest radio dish on Earth. And we wanted to say something to the universe. Frank Drake and his colleagues decided to send out a message. We sent a message out, a signal, written in binary code. We sent the atomic numbers of the elements that make up our bodies. We sent the double helix of our DNA. We sent a simple drawing of a human being. We sent a map of our solar system with the third planet highlighted. Here we are. Here is what we are made of. This is the specific rock we live on. We aimed the massive dish at a cluster of 300,000 stars, 25,000 light years away. And we sent our home address into the dark for 3 solid minutes. In December of 2020, the support cables at Arecibo snapped, and the telescope was destroyed. The thing that sent the message to the stars and listened for replies was silenced for good. But the message is still traveling. It's still moving through space at the speed of light. And eventually, it's going to meet something and tell it exactly where we are. We could go silent tonight. We could turn off every transmitter, shut down every radar, and plunge the Earth into total radio darkness. It wouldn't change a thing. The word is already out. We can't take it back. It's still going. Somewhere. We looked up at the night sky, and we wondered where everyone was. Maybe the answer is that everyone else already learned the rules of the dark. They grew up. They went quiet. And we are the only light in this dark forest that hasn't stopped shining, constantly yelling out into the void, oblivious, into a dark that may already have heard us and may already be answering.